With that, I'd like to welcome you to Minimizing Risk and Uncertainty in CAD Consolidation. Today's presenter is Steve Myers, ITI Senior Technical Consultant. Steve, thanks for presenting today.
Thanks, Margot.
I'm
Good
gonna turn
morning,
things over.
everyone. Great, thank you. Good morning, everyone. Thanks for joining us today. We are going to spend the next few minutes talking about something that if we were to do a poll to say who doesn't want to do this, we'd probably get a 100% answer from the audience saying that no, we do not ever want to have to deal with a CAD migration or moving from one CAD tool to another. We all like our current CAD tools, but as we all know, also there are sometimes compelling business reasons that require us to do what we call here at ITI a CAD consolidation. And just to kind of get everybody on the same page as to what we mean by that, it's a pretty simple explanation. There becomes a need at some point in your business where you, because of various business events, we'll talk about a few of those later, you have the need to move data from your current CAD system into a new CAD system. Your current CAD system I'll refer to throughout the presentation as the source, and then the CAD system that you're moving to would be the target. So here's just a little graphic illustrating that process. Now there's some things. Yeah, go ahead, Margo.
I didn't mean to interrupt you. I was going to say, should we do a quick poll just to find out who on the line, like if they're going to face a consolidation, which system they're going to?
Yes, let's do that.
Okay, let's do it. So here's a quick poll. If you're facing a consolidation, select your system out of these top 5. Unfortunately, we only get 5 options, but go ahead and select which system you're heading to, and we'll share the results with everyone. Give it just a couple more seconds. People are actively weighing in. And if you're just on the line to learn and you're not moving, you don't have to weigh in. I'll just wrap this up here. All right. Share the results. Looks like most people on the line are moving to SolidWorks. That's interesting. So different than our typical results.
Yeah. Interesting, but not surprising. SolidWorks is a popular mid-range CAD tool and has a great big user base and lots of nice resources. So I'm not here to judge anybody's CAD choice, but SolidWorks is certainly a good one.
That's right.
Well,
okay.
Yeah, well, let's move on then. Before I jump off this slide, though, just a couple reasons why you might be changing CAD tools, and those of you who've responded to the poll already know this, but sometimes there's a merger and acquisition where one company acquires another. Sometimes companies acquire product lines from one another, and those products are designed in a tool that's different than the acquiring company is using. And sometimes companies decide, which may be the case with a lot of folks here, that it's time to change the CAD tool for whatever reason, in which case you have a new tool coming online and then you have all of this legacy data that you've got a big investment in, and you want to get the best out of that investment in the new CAD tool. And so when considering a move like this, it's pretty important to have a broad vision, because a CAD migration really is a little bit more, or sometimes a lot more, than just translating your CAD data from one system to another. You want that data to be reusable. You want metadata that's attached to those CAD files to be live and usable in the target system. And then almost always there's a PLM component to a CAD migration. Sometimes the PLM system is the same one that was used in the source CAD tool, and you just move your data to the target CAD tool and you reside in the same PLM environment. I don't think we see that happen too often, but sometimes that is the case. And then in other cases, there's a completely different PLM system in the picture as well. So there are some considerations you want to keep in mind if that's the case, that are, again, beyond just simply translating geometry from one system to another. So it's important to have a broad vision and to include all the right people in the planning and discussing of all of the issues associated with that move. And some of the stakeholders you can see listed here on this slide, if you fit that puzzle together carefully and involve all of those people, then you're going to do what we suggest in the title of this presentation, and that is minimize the risk that you're going to encounter as you move through that process. So we've got IT folks that need to be involved, PLM administrators, CAD managers, CAD users, and then an often ignored group that's becoming more and more important with the spread of CAD data throughout the enterprises, those folks who use CAD derivatives, right? Information that comes out of your CAD models, PDF files, that kind of thing. Those people are consumers of CAD data indirectly, but their input is important, and their needs are important to consider in this kind of a move as well. So obviously, getting all those stakeholders together, the idea behind that is to develop a strategy that includes all the appropriate stakeholders. And there are some really good questions to ask. A couple of them I'll highlight here, and we'll get into some more questions a little bit later. But one of the big ones is, are we going to do this migration as a big bang? In other words, take all of our data from the source system and move it to the target in one big project and push the go button and let it all get translated? Or does it make more sense, and then also, do we have, are we moving from an environment where we're kind of drawing based and we're going into a model based enterprise environment? Is that something we need to consider? What are some possible workflows that we need to clean up this data after it's translated? And you'll hear me say later in the presentation, and I'll say it now, that no CAD translation is going to be 100% perfect. So it's important to have a workflow in mind and in place for the files that aren't going to come through so cleanly, that might need a little extra work to make them as usable as they can possibly be in the target system. And so let's shift gears now and talk about what some of the risks are as you embark on a CAD consolidation. Just paint a little picture here for you. We have Company A, and they use NX, and they acquire Company B, and Company B uses SolidWorks. And in this case, the SolidWorks data is not managed by PLM. This happens with a lot of smaller acquisitions, I would say, where, say, a larger company buys a smaller one, and the smaller company has a small team of designers, and the system that works best for them is to simply manage their CAD data in Windows folders, and that's a fine way to manage a small set of data. So in this case, there's no PLM system in the picture, and Company A is expected to migrate the SolidWorks data to NX and have it as usable as possible in that target system. So what kind of risks are involved here? First of all, Company A, initially at least, has no idea what's in the files unless they can open them all in the source CAD data format, or they can open them all in the source CAD tool. And this isn't always possible. We run into situations frequently where customers who engage with us in a CAD migration don't have access to the source CAD system, but they do have a bunch of model files from that CAD system, but they don't really know what could be missing because they don't have the ability to retrieve that data in its originating system. And the other thing to consider is that even if the data was managed in a PLM system, PLM systems are really good at keeping track of CAD files, and with the right sort of export process, it's rare that files would be missing from an assembly. But even with a PLM system in the picture, there can still be components missing once you extract that data out of the PLM system. And Company A may not have access to that former PLM system. Sometimes migrations originate with a big dump of data that comes out of a PLM tool, and it's then placed in a bunch of Windows folders and handed off to the acquiring company saying, here's our design, good luck, do what you will with it. So that represents some risk. And even if Company A does have the access to the PLM system of the originating CAD tool, may not have the expertise on the team to perform an extract of that data that provides all of the files that are necessary. So these are some of the risks involved in a situation like I described in the previous slide. But The good thing to realize is that all of these risks can either be eliminated or minimized by just considering a few very important points as you plan a migration like this. The right tools and the right strategy can minimize or either eliminate that risk. So some questions to ask before embarking on this journey is, do I have all the files I need? That's probably the #1 question. Second, what's in those files? Are they complex geometry? Are they simple geometry? Are they sheet metal? Do they use specialized capabilities like cabling or pipe routing, things like that? Will this data actually be used in the target system? Sometimes there's data that simply won't be used for various reasons. But assuming the data will be used in the target system, how will it be used? Is it going to be used as a foundation for a new design, or is it maybe, just to use a simple example, perhaps an engine block that isn't really going to change a lot, but all the stuff that we bolt onto that engine block will be designed new and will be actively modified throughout the design cycle, but that particular engine block part could come over maybe as geometry only. We don't care if it's modifiable or not in the target system. So these are great things to consider, and actually essential things to consider as you go through a CAD migration.
Hey, Steve, let me do this. Let's go back real quick and ask the audience one more poll. Let's see if, for those that are doing the consolidation, what % of the data do you plan to convert fully featured? And maybe this webinar will give you some food for thought, but how much right now do you expect you are going to move over with all the features, not a boundary representation, but everything? And we've got some ranges to choose from here, just to give people a feel for maybe where they fit in relation to everyone else. I'll give you a couple more seconds to ring in, and then we'll share these results. Okay, people are still clicking away here. All right, I'm gonna go ahead. Oh yeah, what's that?
I say I'll refrain from making a prediction here, but I have in mind what kind of numbers we might see. We'll see if it.
I'm gonna see if you're right here. Let's share the results. So the majority of people thought 100% was coming over with the features. What do you think?
Yep, that's pretty common. It's very common as we, especially at the beginning of a project like we're talking about here, that the desire would be, or maybe you actually think you need all of the data 100% parametric, and that's a very common initial desire in a CAD migration. What we often find, though, is that when customers begin to look at the data that's being migrated and asking these questions, they often discover that not all of the files require that level of usability in the target tool. Now, there are exceptions to that, but very rarely do we see in our 25 years of experience of doing this that every single part needs to be fully featured, fully parametric, 100%. Now that's possible to achieve. I don't want to make the wrong impression there, because that can be obtained through automated tools and some manual work, which is almost always required to get 100% there. You'll see some statistics on that in a little while, but most of the time we learn through the process of asking these questions and thinking about all the uses of the data going forward that that isn't always required. And as you might guess, the old adage, garbage in, garbage out, certainly applies here, which is really what these questions are all about, right? Especially the one around, will this data actually be used in the target system? No need to drag that along if it's not necessary. So again, with this garbage in, garbage out idea, one of the questions I asked earlier that we had up on one of the earlier slides was, what's in this CAD data that we've acquired? What's the condition of the data? And that's a big mystery, especially if you can't open those files in the source tool. And it's still even a big mystery, even if you can open the files in the source tool, because if we're talking about a data set of, say, 10,000 models, it's a lot of work to open all those models and discover what the quality of those models is and what kind of features and geometry are in those models. So we have a number of tools that we bring to bear in a situation like this, and one of the things that we do is performing an audit. We have a couple of different tools we use to perform that audit, but basically what these tools do, and you can kind of see something scrolling by here on the right, that's our auditor processing part after part after part, in this case in SolidWorks, generating a report that shows us what's in that model or what's in all those models. So if you don't know what you have, you don't know what might be missing. So these auditing services that we're able to provide through the use of our auditing tools, they can analyze a large number of models very quickly, and you don't need to have the source CAD tool accessible. We have all those tools accessible, and in conjunction with our auditing tools, we can perform that kind of an audit and give you the information that you need to be confident that you have everything that you need. And one of the things that comes out of this process is, this is a very simple example, right? It's just a run-of-the-mill spreadsheet without even any fancy formatting, but this is extremely valuable information, because what this is telling us is, of that data set that we acquired from our, of that data set that we require to migrate, these are the files that are missing, so that the auditing tools that we have automatically retrieve all the assemblies and drawings, and if something's missing, that's noted and included in a report. So not only do we know assembly A is missing some components, we know exactly which components are missing from that, so we know what components to look for either in the source PLM tool or in this collection of data that we have in a bunch of Windows folders. And then another type of report that comes out of that auditing process is what you're seeing here, and this really is the meat and potatoes of the auditing process. So not only do these tools provide what files are missing, but sometimes even more importantly, well, once you get past the missing files, then the important thing becomes what is in those files and how friendly is that content to an automated translation process like we're talking about here. So what we have here is a graph that shows all of the different features that were encountered in a sample data set. So what you see in blue on the bar graph there are all of the feature types. Let's assume, I can't remember how many models we had in this sample, but let's assume that this is 500 parts that were analyzed. So you can see over on the left-hand side that spread across those 500 parts, there are about 1,466, I think it says there, extrude features spread over those 500 parts. As you go over toward the right, you can see decreasing numbers of feature types, but the vast majority of them in this case are very common features that we see a lot: extrude, revolve, chamfer, those kind of things. As this feathers out over toward the right, we see less commonly used features and typically more complex features. And as you get over there even further, you'll notice that the bar underneath the graph changes from green to red. That's an indication of which feature types, those above the green stripe, those are supported in the automated migration tool. And over on the right are the features that are not supported for automated migration. So what this tells us for this particular data set is that about 92% of the total feature count in this data set are supported for parametric exchange, which is going to be equivalent to about 87% of the models converted as fully parametric. Now, I don't want you to get the impression that because some feature types aren't supported that we don't exchange that geometry, because in the way it works is that even if a feature is not supported for fully parametric exchange, you'll still get accurate geometry for that feature. It just won't have all that design intent behind it. So that's where you would make a decision. Do we need that information? Can we live with it as is, or do we do some manual remastering of it? So that's what this report is designed to convey, is what percentage of the parts, when we push the go button and run these 500 parts through the translation tool, what are the results going to look like? This is a very good predictor of that. So with that information all in mind, let's look at what the actual consolidation process looks like. So before we kick this part of a project off, we've gathered our stakeholders, we've considered whether we need to migrate all this data at the same time, whether we do it case by case. We've involved IT, PLM folks, CAD consumers of various types. We've taken a sample of the data and we've analyzed it to see if there are any missing files and to see what's in the files that we do have. And now we're ready to gather all this data up into a big repository and point our conversion tool at it and say, go. So what happens then? Well, a couple of pieces of terminology. First, we tend to talk about things in terms of conversion and migration. Now, conversion in our head and in our language here at ITI means we're translating CAD data from one tool to another. And a migration, that word, at least in our terminology, speaks more toward moving data to a PLM system. And most of the projects we deal with have both of these components in them. So there's some pain and opportunities associated with that. But typically, this is viewed as a painful process. It's typically underestimated in the cost and benefit as part of any change of tools that you might do. It's usually the last thing people want to deal with, as we alluded to earlier. But it does represent an opportunity to consolidate information into one PLM system and one CAD system, which, I think with very few exceptions, is a world that most companies would want to live in. One PLM, one CAD, everybody on the same page. It's also a chance to move to a newer and more mature business model as tools evolve and get better. Companies want to take advantage of the benefits that come from those tools, so moves often become necessary for that reason. So here's just an example of, just simplified example of how it works. So we export CAD files from the legacy system, we convert to the new CAD format, and at the end of that process, those files are migrated into the new PLM system. So that's a very high-level, simplistic view of it. But the nuts and bolts of it are kind of interesting too, and we'll get to that in a few minutes. But there are some options before we get to that actual conversion process to understand well, again, before we hit that go button and launch our automated tool on this big data set. Three terms here that we're going to explain and talk about the pros and cons. And the first one is B-rep conversion. Now, most of you probably know what that means, but if you're not familiar with all this terminology, that simply means we're going to take geometry and geometry only and translate it from one system to another. So you won't be able to click on a feature in the target system and edit a dimension. It's dumb geometry, as we say in the CAD world. There's some pros behind that. B-rep conversion is economical, it's fast, it's effective, it's easy to do, but it does lose design intent. It promotes some, I'll say, off or out of compliance actions sometimes by CAD users who may need more information in that model or who may want to remaster that model for various reasons, and there's nothing wrong with doing that. The problem is that when you have 10 different users remastering these dumb solids in different ways, you have a little problem with complying with your CAD standards. So sometimes that can come into the picture. And this way of converting data provides little to no reuse in the new system. And by reuse, we mean being able to modify dimensions, easily change features and that kind of thing. And that becomes a little easier with tools like flexible modeling and synchronous modeling and those things. But even then, it's not an optimal solution if you really need to work on that design in a detailed manner in the target system. So the next option that is available certainly is manual remastering. Some companies do that internally, some companies outsource it. The pros behind that are obviously you preserve your design intelligence, right? You're getting models built from scratch in the new tool. That gives you an opportunity to implement a new design methodology. Maybe you've been thinking about changing your CAD standards and you want to implement that in these new designs as you switch, or in these old designs that you switch to the new system. And it also allows you to take advantage of the new capabilities in that new CAD system that you may not have had before. The cons with that, obviously slow process. You got human beings modeling data that's really already been modeled and essentially doing all that work over again. The labor costs for that can be expensive. And in that case, while that process is happening, your data is frozen for a pretty long time. In fact, most of the time, too long to have an effective migration of that data into the new PLM system. So that's something to think about if you're considering manual remastering. Then there's what we're focused on today, which is automated remastering, and that's a solution called Proficiency that ITI provides. We'll talk about what that looks like in a moment. But the pros behind automated remastering, it's economical versus manual, which is much faster. The migration period becomes shorter, and you do get that benefit of preservation of design intelligence, because as much data as possible that can be translated from the source to the target parametrically is translated that way. There are some cons there because there are some functionality gaps, and one of the things we saw in the audit results file was that or in the audit results slide, was that there are some feature types that simply aren't supported due to low demand for those feature types in some cases, but also due to just really big inherent differences in the way CAD tools handle certain types of features. Some feature types are just not good candidates for automated exchange because of that. And so that's what we mean by CAD system API incompatibility. Sometimes it's just not possible to automate certain feature types for exchange, and that can slow down the migration process. So with these terms in mind, we'll take a look at what a process typically looks like. First off, what CAD tools can we deal with here? So on the left side of the slide, you see all of the source CAD tools that we support, and then over on the left populating, or on the right populating, there are the targets. Now you'll notice that the target list is a little shorter than the source list, and that's simply because the exception there, if you're looking for it, is at Solid Edge. We have the ability to export out of Solid Edge, but we haven't seen a lot of demand to go into Solid Edge at this point, so we haven't yet developed a tool to migrate into Solid Edge. But all the big players are over there, as you can see, and the majority of the folks today are interested in SolidWorks, and that's certainly supported in both directions, as you can see from the slide here. Well, this is kind of representative of what happens, right? We take a bunch of, let's say, PTC Creo files, we run them through this big blue circle that says Proficiency on it, and then we spit out SolidWorks files on the far end. What does that actually look like is illustrated in this slide. So over on the left, in this case, we're going from SolidWorks to Creo. So that's those are the examples that you're seeing on the left and right. But on the left is a model tree from a source file in SolidWorks. Over on the right is the equivalent model tree post-migration, post-translation in Creo. And in the middle is where Proficiency does its magic. So what happens here is we take data using the API for SolidWorks, or the application programming interface, the API for SolidWorks, and we pull data out of SolidWorks into a neutral format that's proprietary to Proficiency. We then map features or recreate features in Creo using Creo's API. So we go from SolidWorks to a neutral format and then into Creo. And what happens in the middle is what Proficiency does. And you can see how we track the results here. So what you're seeing in the middle there is actually a report that's visible as you use Proficiency to do a migration. And it's what we call the feature map. It shows what we had in SolidWorks and what we got in Creo. And there's a one-to-one relationship. Sometimes there's a one-to-many relationship, depending on what feature types were in the source and what we're able to do in an automated fashion in the target. So sometimes you see some variations in the model trees, but typically you're going to see a one-to-one correlation between what we have in the source and what we have in the target, and that's certainly what you see in this case. Another component of this, and this kind of gets more to the PLM aspect of these projects, as I mentioned before, geometry is part of the picture. The other part of the picture is metadata that is associated with CAD files. Most of the CAD models that we process and the customers we work with have some kind of metadata, sometimes very simple, sometimes very complex, attached to their CAD models. And most systems, it takes the form of what some systems call properties, other systems call parameters. But the bottom line is those bits of information are contained in the solid model. They're often displayed on the face of a drawing or displayed in the 3D world as labels and notes and things like that. Those pieces of data are important not only to convey more information to designers, but also to provide information to the PLM tool about this model. Lots of people have to look at the PLM system to look only at metadata, may never even look at the geometry of a particular part, but the metadata is important to what they're doing, so that's the information they need. So we preserve that information. That information is preserved in Proficiency, moving from one system to another, and can be preserved in a number of ways. Sometimes all that's required is what you see here, where it's a one-to-one. Each property in the source file gets a property named the same thing with the same value in the target system. Sometimes it's maybe cage code or description isn't really the term that you use. So there are capabilities to map these parameters, I'll call them, map these parameters to a different name in the target tool. There's lots of flexibility around that. The bottom line is you not only get geometry through this automated process, but also all the important metadata that makes this design even more useful in the target system and enables you to integrate PLM into the picture. So just a few examples here. These are just snapshots. So this was a part that was brought. Actually, this is sorry, I've got things reversed there. So this part is in Inventor and came from NX. And I think, I think this one's reversed too, so pardon that. So this one came from Inventor into Creo, just to give you a cross-section of the type of parts, and this one was actually from SolidWorks into Creo. The reason I show these is to give you an idea of what types of data are really, really successful, right? These parts all came through 100% parametric in the target tool, modifiable there as though they've been built initially in that system. But as I mentioned before, there are instances where not all the geometry or not all the features are able to be translated automatically, and when that happens, there are some business decisions to be made as to whether we're just going to work with geometry for those parts. And again, often we find that is the case and that is good enough. You know, sometimes you're faced with the business decision to go with perfect or good enough to meet our business needs, and oftentimes that is the case. So I think that's about it. If you have any questions, Margot will, there might be some questions already, but I've said a lot in a short period of time, and we want to give you a chance to ask questions and ask for clarification on anything that you've seen today.
Yeah, feel free to send them to me in the question window as we go here. We do already have some questions that I'm going to fire over to you here, Steve.
Okay.
One question is about evaluating duplicate CAD data in this process. I do know our PLM migration team, has a process where they evaluate the data set, generate reports, and help you clean and fine-tune things before your big bang migration. But what about the actual CAD conversion process? How do you handle duplicates in that sense?
Oh, that's a good question. Yeah, if there's a PLM system in the picture, that problem solves itself because PLM systems don't allow duplicates. So in that case, whatever you export from PLM isn't going to have duplicates. But in the situation like we described in our little case study here, things are managed in folders and there may be duplicate files. So in that case, we can spot those duplicate files, but really the only way to know for sure if those duplicate files contain the same geometry is to open them. Some comparisons can be made looking at the file size, but that is likely only going to indicate whether, the only thing you could be sure of is that file was perhaps changed and saved at a later date. So those things can help you sort that out. But if they're duplicates and you really don't know what's in them, then sometimes the auditor can tell us that information, because if we see that the feature content in terms of what types of features, let's say part A has 5 extrudes and a revolve, And the other part A that came out of the other folder has, 2 sweeps and a couple of surfaces. Okay, we know those are different files. So at some point, you would need to decide what names are these files going to have, because certainly we don't want those duplicated files to wind up with the same name in the target system. So
Very
that
good.
can be a tough one, but not insurmountable. We can discover those things using various means, but in the end, a decision does need to be made about whether both files are necessary or not.
And I'm going to skip around here on the questions. I'm going to ask them out of order because this one that just came in relates. Can parametric assemblies having relations between parts or assembly level features be captured as well?
Oh yeah, absolutely. And yeah, we didn't really cover that in detail here, but the short answer is yes. What happens is that the system will recreate constraints, mates, inserts, aligns, those sort of things in the target tool to the extent that it's possible to do that automatically. And of course, the next question that comes to your mind is, okay, what if it can't be done automatically? In that situation, the model is placed in the correct orientation and position in the assembly, and any constraints that can be recreated are recreated, and then the model is fixed in that position so that you could go into the new CAD tool and construct constraints that are appropriate in that new system, or simply leave that component as is, knowing it's going to be in the right position and the right orientation.
Okay, very good. Someone did ask, we've shown the example that we support Creo parametric. What about Creo elements?
Oh, that's a good question. Now, Creo Elements is I have a lot of experience at PTC, so I know what you're referring to there. The evolution was from Pro Engineer over to Creo, but in between that name change, there was a product called Creo Elements. And if you're talking about Creo Elements Parametric, there were a couple of different versions. Creo Elements Direct and Creo Elements Parametric, I think, were the two names. If it's the parametric version, then it won't be a problem, simply because files are always upward compatible. So the earliest version of Creo that we support right now is Creo 3, but those Creo Elements files will be retrievable in Creo 3, and so processing them through Creo 3 and then into the target tool of, in this case, say it was SolidWorks, won't be a problem at all. The only thing that becomes a problem is if you have CAD files that are newer than our latest supported version, right? So like right now, we're not supporting the 2020 versions quite yet of SolidWorks and Inventor. So if you had 2020 files, then then we'd have to have a conversation about when that support's going to come online, because we typically lag behind a couple of months or so, because we don't get access to the APIs on the same schedule that customers get the new product.
Yeah. And one thing, couple questions, I'll just clarify too. Someone was asking whether we sell software or do we just do this as a service, and the answer is both. So
Yeah.
we consult with you if the decision is made, you have such a frequency or volume, you want to do this yourself, you can certainly buy the software and do it yourself. I see a trend that most people love our kind of hands-off approach where we just handle it for them as a service. So both are available to you for those that wanted to know. And then another question was about drawings, making sure that we also support drawings as well as the models, and we do.
Yep. Associated drawings are translated, but I want to make sure everyone understands the important part about drawings. Drawings are different animals enough between the CAD tools. We certainly exchange them, and the relationship between the solid model file, the part or assembly file, and that drawing, that's all maintained, but you will have to do some manual work on any drawing that's translated. So for a lot of customers, when they're migrating, they decide that what a lot of our customers do is they say, okay, we're gonna pretty these drawings up when we need to, as that data is used in the target system. And for the meantime, there are two options available, and most companies exercise both of them. One is to output a PDF of the drawing as it's translated. So not only do you get it translated in the target tool, but you also get a PDF of that output. So you've got that record of that snapshot in time. And then on the drawing that gets translated parametrically, there is what we're able to get translated on the face of that drawing, but there's also a background image that shows exactly what was in the original drawing. So a visual inspection will reveal immediately any areas that need attention on that drawing.
Great. Okay, it looks like we only have one more question. If anyone does have any more questions, go ahead and send them now. There was a question about, what about files that go through this process, but then the quality isn't great? Like you've identified that it's, like you said, garbage.
So, yep. It's, this isn't a 100% perfect process. So there are really a few different options. Let's suppose we have a file that comes through and none of it can be processed, can be automatically processed and have a parametric result. In that case, you're going to get a file that looks as though you'd imported a step file into the target tool. So it's going to be a chunk of geometry that's accurate, and it will have the parameters or the metadata that came out of the source tool. It will also leverage the start files from the target tool. I didn't mention that earlier, but we incorporate your start models into that process. So you may have a piece of geometry that is, again, quote unquote, dumb geometry, but you do get the metadata and the advantages of your start part there. If that's good, then you live with that. If not, in that case, then of course it's going to be a manual remastering. But I think the vast majority of parts that are questionable like that are usually a combination of parametric features and then non-parametric geometry attached to that we were able to provide through the automated process. Those parts have several options as well. One is simply live with the chunk of dumb geometry that results at the end of the model tree, which is the entire part represented as, again, a B-rep or like a step translation. But farther up the model tree, as you go toward the beginning of the model, you're going to see parametric features that came through just fine. You might also see non-parametric features, which are going to be chunks of geometry that are integral to the solid. You might also see what we call placeholders, which means at this position in the model tree, there was a feature that we couldn't get fully parametric, but we were able to get the sketch and a couple other items, and those will be nested underneath that placeholder in the model tree. So what that allows you to do, again, is either live with the B-rep at the end of the model tree, or you get a huge head start in remastering this. The parametric features you leave as they are, you go back to the features that have placeholders, and if they have some partial information or partial pieces of sketches and things like that, you get a head start on those features as well as you bring them up to the standard that you require.
That's great. Well, I'm going to squeeze in one more question. For very old legacy models and drawings, do you recommend exporting neutral formats like DXF or STEP to allow for ease of migration?
Well, that is certainly an approach you could take, and I'll state the obvious here, which you're probably already thinking about, is if that's what comes out of the, well, let me back up. In that case, if that's really what's required, and we either for reasons of the geometry is too complex, or it's not supported, or it's, for whatever reason you want geometry in the target tool and not features, there's an option to process a set of files as geometry only. I wouldn't recommend exporting as step. I mean, you could certainly export your geometry as step, but that doesn't help the automated exchange process at all. The automated exchange process can exchange files using what looks like step and results in only geometry in the target tool. So in that case, you're kind of like batch processing this export of geometry only. But exporting it from the target system into a step format, that's not really a valid input to this automated process. If you're going to do that, then you'd either just process all the geometry using our automated system using geometry only, or simply do a batch step export from your source tool and not bother with the automated process at all. However, let me say, in having said all that again, the advantage of using proficiency in that situation is that you get to use your start models that you have established in the target system, and you get metadata that was attached to those files in the source tool. So that's a strong case for using automated exchange, even though you're only exchanging geometry and no features.
That's great input. And if that needs further fleshing out, feel free to reach out to us after. I'll be sending an email to everyone that registered today, so you can always reply with more questions or ask to talk to Steve. Steve, I already have somebody wants you to call him after. So
Sure.
yeah, we're very reachable. Just let us know. And thank you so much for 45 minutes of your day. I know some of you it's the morning, and some of you in Europe, you're ready to go home. So thanks again. You're very welcome for joining us. Thanks, Steve.
Yep. Thanks, everyone. Have a good day or night.
Bye.